Welcome to this Maths Made Easy video on differential equations. And to start with, let's take a look at solving differential equations. Now at A level, all differential equations have the form dy by dx is equal to f of x times g of y. Okay. Now in this case, we can treat dy by dx as a fraction and rearrange this. So, using this expression here, the first thing we do is divide the left hand side and the right hand side by g of y. So what that gives us here is 1 over g of y times dy by dx. Okay, and this is going to be equal now to f of x. And finally, the next thing we do here is just multiply by this dx. Okay, so that gives us 1 over g of y dy, and this is equal to f of x d of x. Okay, and now that it's in this form, we can integrate the left side with respect to y and integrate the right hand side with respect to x. Okay, so simply what that would give us here is the integral of 1 over g of y dy, and this is equal to the integral of f of x with respect to x. Okay, and once we've integrated, we can get our final answer by rearranging to get y in terms of x. Now this answer will include a plus c from the integration, and you only need to include this on one side. Sometimes the question will contain extra information, sometimes known as the boundary conditions, to help you determine the value of c. It's important to note here that we wouldn't usually treat dy by dx as a normal fraction, but we can in this case. So that gives us everything we need there for working on solving differential equations. And finally, let's take a look now at real life problems. So sometimes you'll be required to form a differential equation based on a real life problem. So we can see from this example here, we've been told the rate at which the size of the goldfish S is increasing is inversely proportional to the current size of the goldfish. And what we want to do here is form a differential equation for this scenario. Well, the first thing to note here is ds by dt is the rate of change of S, the size of the goldfish, with respect to t, which is time. And this is inversely proportional to S. So in that case, we can express this here as k over S. Okay, and that's for some constant k there. Okay, now as we can see from this example, real life differential equations often don't use x and y, but they will use other variables. However, they can be solved in exactly the same way. It's important to note that real life problems will also sometimes contain extra information. These are known as the boundary conditions, and these are helpful to determine the constant of integration. If a question involving time provides a starting condition as its extra information, this is the value of the parameter when t equals 0. You may also be asked to list limitations of modelling a real-life problem with a differential equation, and there's a few reasons you could give here. So for example, we could mention that there's not enough information, so there's no information given to determine the value of constants that have been provided. Another reason we could give is that the model may not work or could break down at very large or very small values. Another reason we could give here is the appropriateness of the model. So for example, a continuous variable to monitor a population which is discrete obviously would be a drawback there. Okay, so that would be not appropriate in that context. And finally, any other things that have not been included. However, this will vary based on the question and the context, so it's important to keep an eye open for that. So that gives us everything we need there for real life problems, and that concludes this Maths Made Easy video on differential equations.